Welcome everyone to our second grade 11 maths session. Today we're going to be looking at equations and inequalities. This is your first section you'll see in your final exam, and it's a very, very important section. If you, when you get to matric, it's exactly the same. There's no additional work covered in matric. So your first two or three questions in your final matric exams are equations and inequalities from your grade 11 syllabus. It's also really important that you understand equations and inequalities so that you can then apply it to your functions and other sections that you will need to do when you are in your maths paper. All right, so we're going to go over equations and inequalities, and hopefully it'll make a little bit more sense for anyone who was confused. All right, if you are joining us live or if you're at, online watching on YouTube, I suggest you grab a piece of paper and a pen and do these questions with me so that you know exactly what's going on and you're practicing as we go. So your basic equations from grade 10 and below were generally linear equations, and quadratic equations start to become more important in grade 11 and 12. So for your linear equations, what we had to do was bring all the x's to one side. So we would have gotten 3x on the left-hand side equal to 12, and then divided both sides by 3 to get 4, and that was our solution. Very basic linear equation. But when we have quadratic equations, if I bring the x's onto one side, we get x squared plus x is equal to 12. And that we can't simplify any further since x squared and x are unlike terms. So what we do for quadratic equations is we rewrite everything on the left-hand side, set it equal to 0. And this is really important. If we set it equal to 0, we can use what's called the zero factor rule. So if I factorize this quadratic on the left-hand side, right, I know that I'm going to have two brackets. The negative from the negative 12 tells me one of the brackets will have a positive and one will have a negative. So the signs are different. And I'm looking for two numbers that multiply to give me 12 and add together to give me 1, which is the coefficient of x. So those two numbers that work are positive 4 and negative 3. Positive 4 times negative 3 is negative 12, and positive 4 minus 3 is 1. Now, I've factorized on the left-hand side, and it's equal to 0. Because it's equal to 0, we know that anything multiplied by something else that gives an answer of 0 means that either one of those factors must have been 0. So this zero factor rule for solving quadratics only works if you rearrange and get this 0 on the right-hand side. Once we've gotten our two zero factors, we can then rearrange and solve it as we would a linear equation, and we get our two answers. X is equal to negative 4 or x is equal to 3, because either one of those would have meant that this line over here would be equal to 0, and so we've solved our equation. This is one of your basic ones. They do get more difficult, so we're going to continue on with solving these quadratic equations. Here, we've got 2x squared minus 7x equals 4, and it's good to be able to identify how do we know it's a quadratic equation. We know because there is a square, there is an x, and there is a constant. So when we've got our quadratic equation, we are now going to rearrange, make sure everything is in standard form, everything on one side of the equation equal to 0, and now we need to factorize. But now we see that it's slightly different to the previous equation. We now have a coefficient of x squared, and we have a constant. So this coefficient of x squared is 2, and our constant is negative 4. So we need to be able to factorize with those two constraints. So we look at the factors of 2. We only have 2 of them, 2 and 1. And then we look at the factors of 4. So let's try 4 and 1. We do a little cross multiplication. 2 times 1 is 2. 1 times 4 is 4. The negative on the 4 tells me that one of these is a positive and one is a negative. And we're trying to see if we can get to -7 by adding. So if I have a positive 4 and a -2, then I end up with a 2, which doesn't work. Maybe I have a positive 2 and a -4. That gives me a -2. That doesn't work. So this attempt didn't work for us. So we're going to rewrite our factors maybe in a different order. We can do this cross multiplication thing, and we assign one of them a negative and one of them a positive. And this we see will work. -8 plus 1 is equal to -7. So that tells me I've picked the correct factors in the correct order. So now when we're working out our bracket, this will be one of our brackets, and this will be the other bracket. And the sign that we've got on the right-hand side is the sign for each of the brackets. Remember that we do need an x as well. So this is 2x plus 1. That's our first bracket. And then we've got 1x minus 4 as our second bracket. You may have learned different techniques in solving these quadratic equations. This is just one of the techniques that I like to use, but go with whichever way is more comfortable for you. We still end up at the stage where we have a 0 factor. So we can say either the one factor is equal to 0 or the other factor is equal to 0. Remember, we can only do this since we've got a 0 on the right-hand side. Here we can rearrange 2 of x, 2x equals -1, so x equals -1/2, or x is equal to +4. And we've solved our quadratic equation by factorizing. Now you could be asked for factorizing, which maybe isn't factorizing a trinomial, like this example. You might have to factorize using common factor or perhaps dots or even grouping. So you need to make sure that you go over your factorizing techniques that you would have learned in grade 10. So your factorizing techniques, you always start by looking for a highest common factor. We didn't have one in this example, but you could have a highest common factor and you want to take that out first. Then you could look for the difference of 2 squares, or maybe the sum and difference of cubes. And then you've got your trinomial types or your quadratic trinomials, which is like the one we did now. And you've also got your option for grouping. So those are your different factorizing techniques, and you need to make sure that you're comfortable with them so that you can apply it to your quadratic equations. All right. Sometimes our quadratic equations cannot be factorized with whole numbers like the previous example. And the trick or the clue that tells you you probably can't factorize it is the question will give you a hint. It'll say you need to solve this correct to 2 decimal places is most often the instruction. So this is taken straight out of a past paper, this question here, and they've told you correct to 2 decimal places. So when you've got that, that is the clue that you need to use the quadratic formula. Our formula is given in the formula sheet. Okay, it's over here. I've written it out for you, and you can find it at the back of all your exams, and you should have it for your tests as well. It is given to you. Now, this formula only works if your equation is in standard form. We have our equation in standard form, 5x squared plus 6x minus 7 equals 0. So it's equal to 0. Everything's been simplified. And then what we see, the a, the b, and the c values are the coefficients. So a is the coefficient of x squared, b is the coefficient of x, and c is the coefficient, is the constant. So we can solve this by saying x is equal to, no factorizing needed, and we use our quadratic formula. B in our case is 6 plus or minus the square root of b, which is 6, 6 squared minus 4 times a, which is 5, and c, which is negative 7, all over our 2a. And if you type that into your calculator, so do it with me, typing it into your calculator, you should get your answer for x. It'll be given, you can't type in a plus minus, so you're going to have to do it as two separate equations. And our first answer, if we write it in decimal form, is going to be 0.73 if we round it off to 2 decimal places. And then if you type it in again with a negative, you're going to get x is equal to negative 1.93. Make sure you're rounding off at this step, and make sure you are showing your substitution step. It is really important to have that shown. It's worth a mark when your work is being marked. All right, we're always gonna, well, often we end up with these two solutions. It's the maximum number of answers for quadratic equations. Sometimes they are identical and you get one answer, which is fine as well, but maximum 2 answers. All right, so those are our quadratic equations and our linear equations. You would have done them in grade 10. So what we're going to look at now is your inequalities. So linear inequalities, you've done this in grade 10. Remember, the main rule with linear inequalities is if you times or divide by a negative, you need to change the direction of your inequality sign. So I've put that over here. That is our main rule for linear inequalities. So here's an example. Let's recap how they work. They work very similarly to a linear equation. We're going to want all the x's on one side. So 5x minus 7x is greater than or equal to 13 minus 3. So if we simplify, we get negative 2x is greater than or equal to 10. Now, I need to get x by itself. So I need to divide by negative 2 at this stage. When I divide by a negative, my inequality changes direction. 10 divided by negative 2 is negative 5. And there's my solution. But you have to remember that we are changing our inequality sign. And at this stage, where we are dividing by negative 2, our equation, or sorry, our inequality becomes less than or equal to. You could, of course, have calculated in a different way. I put my x's on the left-hand side. You could have put your x's on the right-hand side, in which case you wouldn't have been dividing by a negative. So let's actually do that. If we take the same equation, but this time we put the constants on the left and the x's on the right. 3 minus 13 is negative 10. 7x minus 5x is 2x. And now I need to divide by 2. I don't change sign. I keep it as this greater than or equal to sign here. And we see that x is less than or equal to 5. It is the same solution, just read in the opposite direction. So both of these are valid solutions. It depends on whether you end up with a negative coefficient of x or not, but you'll end up with the same solution as long as you remember to change your inequality if you are dividing or timesing by a negative. All right, so that's our linear inequality. They could ask you some where you have to do distribution first. This is a very basic linear inequality, but the main point is this: you need to change the sign if you're timesing or dividing by a negative. But I want to focus on the quadratic inequalities today because that's your grade 11 work. Now, quadratic inequalities do not work like quadratic equations. We cannot just make this inequality sign work like an equal sign. We have to consider different sections or different values of x. So let's just do an example. We still want to get it into standard form. So I still want to get this x squared over, and we get x squared minus 2x minus 8 is greater than 0. I still want to factorize. So I know I'm going to have one bracket with an x minus and one bracket with an x plus. Remember, that's because this constant has a negative, all right? So I factorize. I need 2 factors of 8 that will give me -2 when I add them together. And so we're going to get -4 times by +2, because that will give me -8. And -4 plus 2 gives me that -2 that I want, the coefficient of x. So we factorized, and it's greater than 0. Now, from equations, I know that when x is 4 or when x is 2, this expression on the left-hand side is equal to 0. But the question is asking, where is it greater than 0? And I can't just say, well, I don't know, greater than 4 or less than 4. How do I decide? So we write down what we call our critical values. These are the values of x where our expression on the left-hand side is equal to 0. So this is as if we were solving it as an equation. We would get a critical value of 4 and a critical value of -2. This is where it's equal to 0. The question asks, where is it greater than 0? So what we need to do is draw up a little number line for ourselves. Once again, there are different ways of doing this. I find this the easiest. Putting your critical values on your number line, we know that they will be equal to 0 at this point. Now, I don't want to include these 2 points in my solution, since the question is very specific and asks me where is it strictly, figure out where our expression is positive and where our expression is negative. So if you type in any value on this side of your equation, so any value less than -2. So let's try with an x equal to -3. I'm going to do it in a different color because this you wouldn't write out. But if x is equal to -3 and we put it back into our expression at that stage, we need to see whether the answer gives us a negative or a positive value. So -3 squared minus 2 times -3 minus 8, and we will see that our answer is 7. Okay, so it is a positive, it is a positive answer. If you type in a value between -2 and 4, say 0, you're going to get a negative answer. And if you type in a value greater than 4, you will see that you get a positive answer. So you've just picked random x values less than -2, between -2 and 0, and greater, between -2 and 4, and greater than 4. Now, the question is asking, where is it greater than 0? So that is positive. So our solution is going to be any values greater than 4 or less than -2. Because greater than 4 gave us a positive answer, which is what we want, and less than -2 gave us a positive answer. Now, the question could ask you to just solve for x, in which case we would say x is less than -2 or x is greater than 4. Or they could ask you to represent it on a number line, which is what I've done on the left as part of my working anyhow. You can also use interval notation if you prefer to express this answer. It is also really important that you use the word or. It seems a bit silly, but x cannot be less than -2 and greater than 4 at the same time. So we use the word or. All right, so here are our steps for quadratic inequalities. Standard form, that means everything on the left equal to 0 or greater than 0 in our case. Factorize, or you could use a quadratic formula if you can't factorize it. And we factorize so that we can find the critical values, the values of x where our expression is equal to 0. We use a diagram. Some of you may be used to using a parabola. You can use a number line, and that helps us decide in which segments of the graph or segments of the number line our expression is greater than 0 or less than 0, depending on the question. Okay, so those are our quadratic inequalities. If you have any questions, you're welcome to ask in the chat. I'm going to keep going. All right. Simultaneous equations. You will always get a simultaneous equation. And they're fairly long and they're worth a lot of marks. Generally, they're worth about 6 marks. And this is a section where you really can score marks because every time you get a simultaneous equation, it's a fairly standard question. You're going to follow the same steps. You're going to know exactly what to do. It is a routine question and it's worth a lot of marks. So pay attention, make sure you understand, and then you should be fine with these. There's a question about the critical values. Yes, of course. So if you cannot factorize, which I did at this stage here, you can go straight to using the quadratic formula and you will get your critical values as decimals. Yeah, that is exactly what you would do. So you'd skip out your factorizing step, go straight to your critical value step, and then you'd be able to put it in your diagram. All right, back to our simultaneous question. We have 2 equations. One is a linear one and one is a quadratic one. And we need to solve for x and y simultaneously. Your steps are the same each time. Isolate a variable, sub and solve, and then sub and solve. So you're going to pick the simplest equation, which is going to be your linear one, and you want to isolate one of the variables. Now, luckily for us, the question already has the variable isolated. We've got x is equal to, x is by itself. They don't always give it to you with one of the variables isolated. And if that were the case, you would do a little bit of rearranging to get one of your variables by itself. The second step is to sub and solve. So I'm going to get my second equation, which is x squared minus 2y plus 3xy equal to 6. And I'm going to sub in the expression for x that I got from my previous equation. So 2y plus 1. Everywhere where there is an x, I'm going to replace it with 2y plus 1. Remember, it's a substitution, so you need to use brackets. So we sub. Now we need to solve for y. And we have to do a whole bunch of simplification. So your algebra from grade 10 is really important. We are squaring the first bracket. So that means I'm gonna write it out slowly. 2y plus 1 is being squared, so it's being multiplied by itself. Then here I'm going to multiply the 3 into the bracket to get 6y plus 3. It then still needs to be multiplied by y. So we're going to do FOIL. We're going to get 4y squared plus 2y plus 2y plus 1. So that's by our binomial being squared, minus 2y. Our second bracket, we need to do distribution. We get 6y squared plus 3y equal, or let's kind of rearrange it into standard form at the same time. I'm going to bring that 6 over and make it minus 6 equals 0. Now I need to simplify everything. I've got a 4y squared plus a 6y squared, which gives me 10y squared. Plus 2y minus 2y plus 3y gives me positive 5y. And positive 1 minus 6 is minus 5. And we end up with a quadratic equation again. You will see quadratic equations come up all the time in your grade 11 and 12 syllabus. So here we can see there is a common factor. So I can divide throughout by 5. So that will give me 2y squared plus y minus 1 is equal to 0. And so we need to factorize this using our quadratic trinomial knowledge. So our factors of 2 are 2 and 1. Our factors of 1 are 1 and 1, so there's no option here. We get 2 and 1. I want to get a positive y out at the end. So if I have a positive 2 and a negative 1, that will give me a positive 1 as my answer. So my two brackets are going to be 2y minus 1 and 1y plus 1 equals 0. So my solutions for y are a half or negative 1. So that is my second step that I've done now. I've subbed and I've solved for y. But now it's a simultaneous equation. You always want your x values as well. So that's the third step, sub and solve. You can choose whether you want to sub it into the linear equation or the quadratic equation, but it is far easier to solve linear equations. So when y is a half, I'm going to go back to this first linear equation that I had at the top there, and I'm going to sub in my y value that I solved for, and we can get the corresponding x value, which is going to be 2 times a half is 1 plus 1. We get x is equal to 2. When y is equal to negative 1, x is going to be 2 times negative 1 plus 1, and we get negative 2 plus 1, which is negative 1. So my solutions are a half and 2, or negative 1 and negative 1. You need to have your y value and your x value, and your y value and your x value here as well. It's a fairly long-winded process, but you're going to get the same type of question almost every time. So if you can practice this, you are almost assured of a 6 marks in your equations section. All right, we're going to move on to our next type of equation, which is surd equations. Surd equations involve square roots. So to solve our surd equations, we need to get rid of the square root. And in order to do that, we're going to have to square. Now, before I square on both sides, I want to get the surd by itself. I want to isolate the surd. So I'm going to rearrange so that I can isolate the surd. It'll make squaring far easier. Once I've got the surd, the square root by itself on one side of the equation, I square both sides of the equation. So if I square a surd, square a square root, I'm going to just get 2x plus 1. And on this side, I need to square this binomial. Now, we are squaring a binomial. You cannot just square each term. You have to think about it as your binomial being multiplied by itself, and then we use FOIL to get there. If you know the shortcut, go ahead and do it. If you struggle, write it out twice. Negative 1 times negative 1 is positive 1. We're going to get negative x plus x squared. So if we rearrange, we end up with this situation. And what do you know? It's a quadratic equation again. You see how often these quadratic equations come up. So now we need to rearrange and solve. I'm going to put everything on the right-hand side. So we're going to get x squared minus 2x plus 1 minus 1. I've rearranged and I'm going to simplify. We get x squared minus 4x. Now this is nice. I can take out a common factor of x and I don't have to do trinomials. So our solution here is, I'm looking for an eraser. Our solution here is either x is equal to 0 or x is equal to negative 4. Now, the last step for surd equations, which is vitally important, is to double check your solution. If we sub in 0 back at the top here, we're going to get the square root of 1 minus nothing equals minus 1. And that doesn't work. If we sub in negative 4, we're going to get the square root of negative 8 plus, my solution is positive 4. That makes more sense. We're going to get the square root of 9 minus 4. So that's 3 minus 4 is negative 1. So this solution works. but this solution does not work. Okay, when we sub in a 0 back into the original equation, we do not get left-hand side equal to right-hand side. And so we remove the solution and underline the correct one. So checking your solution for a third equation is really, really, really important. I suggest you do it every time. There are ways to check just by inspection which one would make sense, but the easiest way is just to sub it into your calculator and get the answer. All right, so those are your steps for third equations. Isolate the third, square both sides, then you solve, and often it ends up being quadratic, and then we check our solution. All right, our last few equations are exponential equations. We're going to go through 3 of them, and that will be it for our equations and inequality session today. Now, exponential equations come in 3 forms: your basic type, where your variable is in the exponent, a factorizing type, also with the variable in the exponent, and type where you have rational exponents. So we're going to go through each one with an example. Okay, here we have 16 to the x times 2 to the x plus 1 equals the 5th root of 4. For equations, exponential equations, we always want to write the bases the same. So 16 is 2 to the power of 4. 2 to the power of 4 is going to give me 16, and so we rewrite it as 2 to the power of 4 to the power of x, which means we're multiplying. So we get 2 to the power of 4x times 2 to the x plus 1. And on this side, I want to rewrite my third with an exponent. So we can rewrite this as 4 to the 1/5. I can use my multiplication law, which says if the bases are the same, you add the exponents. So I'm going to get 2 to the 5x plus 1. And on this side, I want to rewrite my base with a base of 2. Now 4 is 2 squared. So I get 2 to the power of 2/5. Okay, if I make it 2 squared. Now what we see is there is a single exponent on the left and on the right, and the bases are the same. So that is our first kind of step to make the bases the same. Once the bases are the same, we can equate the exponents. So that means 5x plus 1 should be equal to 2/5. And we get a linear equation. So 5x is 2/5 minus 1, which is going to give me minus 3 over 5. Timesing both sides by by 5, we get -3 as our solution. So make the bases the same, equate the exponents, and then we can solve. You can always go back and double check by subbing in -3 in your original equation and checking that left-hand side equals right-hand side. The second type is if we need to factorize. So our first step is still the same, making the bases the same. If we look at this question, we have 2's and a 5. So we can't really do anything as it stands. 5 is a prime number already. But what I can do is I can rewrite 2 to the x plus 1 as 2 to the x times 2 to the 1, and 2 to the x times 2 to the -1. So what I've done is I've kind of reversed the multiplication law, so that instead of having a single term, it's still a single term, but it's now written as 2 to the x times 2 to the 1. And the reason I did that is because I had nothing else that I could do, and maybe factorizing is going to help me. So if we look at this equation now, I see that I have a common factor. In this term, I have a 2 to the x, and in this term, I have a 2 to the x. So I can take out 2 to the x as a common factor. Sometimes you'll end up with quadratics that you have to factorize. Sometimes you'll end up with dots, there's a whole bunch of different answers or different routes that you could take. In this question, we have to take out a common factor. Now, 2 plus 2 to the negative 1, you can tap it in on your calculator. It's going to be 2.5. We need to get our exponent by itself. So 2 to the x I want by itself. So I'm going to have to take 5 and divide it by 2.5, and we get an answer of 2. We can see now that our bases are the same. And if our bases are the same, we can equate the exponents, which means x is equal to 1. So for this step, what I had to do in this case was split up my exponents and rewrite them using the reverse of the product law. Then I had to factorize. I had to isolate my exponent and then make the bases the same. And then I can equate my exponents. Those were the steps here. Now, it does depend on the question. You might get some different type of factorizing. Your first step may be different. But really with exponential equations, the biggest thing is, can you get the bases the same, which is what I got over here, with a single exponent on one of the sides. If you can get to that step, you can equate the exponents and solve for x. All right, as always, if you've got questions, let me know in the chat, but I'm going to keep going so we finish on time. Okay, our last type of exponential equations are the type where we have rational exponents. So what I mean by rational exponents is that my exponent is a fraction. So now the x, the variable, is the base, and the exponent is the number. Okay, so we know from surds and exponents really that x to the power of 3/2 is the same as the square root of x cubed. Okay, that is from our surd definition. Now you could use this to solve your equation if you wanted to, and then we would realize that we would have to square both sides. So let's actually do it like that. We are solving for x, so I'm going to square both sides, and so I get x cubed is 8 squared, which is 64, and then to get x by itself, I'm going to have to cube root both sides, and I cube root 64, and I get my answer of 4. That's one way of solving it. Another way of solving it is a little bit easier, actually. We can get rid of the denominator of 2 by raising the left-hand side to the power of 2, in which case I get x cubed is equal to 8 squared. And then I can cube root from here, the cube root of 8 squared, and we get the same answer, x is equal to 4. It doesn't really matter. This way just kind of avoids using the surd definition, which is up to you. Now, with rational exponents, you always also need to check your solutions. I think our solution works quite fine here, but when we have negatives involved, there are always the possibility of issues. So let's just talk about that. When would we have an issue with rational exponents? If you get x to the power of 1/2 equal to, let's say, -4, that is an issue because x to the 1/2 means we're square rooting x and we're getting a negative answer, in which case there is no solution. Square roots are always positive. So if your rational exponent has an even denominator and it's equal to a negative, there is an issue. So here where I've got my denominator of 2 equal to a -4, that is a problem. I'm going to have no solution. We also have issues if we end up with a negative answer for x. If we ended up, let's say, if our question, I don't know, was x to the 1/2, and when I solved, I got x is equal to a negative something, -3, that would be an issue as well, because if I sub it back in, we end up square rooting a negative. So instead of having to learn all the different situations, I'd rather just go and check each of the solutions when I have rational exponents. All right, we've gone quite quickly through most of the equations and inequalities section. We haven't spoken about nature of roots, and we've almost run out of time. I'm just going to quickly go through your nature of roots section. We have our quadratic equation, which is given to us in the top right. And sometimes our solutions will be real, equal, rational. Maybe they'll be non-real, unequal, and irrational. And we always need to check if the question asks us about the nature of roots. Now, the part of the equation that tells us the nature of roots is this square rooted part over here. So if I can look at the square rooted part, I can decide whether my equation is going to be real, non-real, equal, unequal, etc. For real roots, we want to be square rooting a positive, okay, because you can't square root negatives. So that's why it says delta is greater than or equal to 0. And delta is exactly what we end up with under that square root sign. So for real roots, you want to be square rooting a positive. For non-real roots, that's when you are square rooting a negative. And that's why we see delta is less than 0 or delta is greater than or equal to 0. Equal roots would mean when I sub in, I get two answers that are the same. Now, the part of the quadratic equation that gives me two answers is the fact that I have a positive surd and then a negative surd. So if this whole thing after the plus and minus was actually 0, I'd be adding 0 or subtracting 0, and I get the same solution both times. So that is why we've got our delta equal to 0 for equal roots and our delta not equal to 0 for unequal roots. Because if it's equal to 0, I get plus or minus the 0. And if it's not equal to 0, I get plus something or minus something, which would give me two roots. Rational roots are when our surd is a perfect square. So if I'm square rooting a nice perfect square, then I'm going to get rational roots. And irrational roots would be when the surd is not a perfect square. Now, I haven't got examples on these because there is no time, but that's just a summary of your nature of roots. Most of the questions that I've looked at today have come from these past papers, this DBE November 2018. Some of them you can see our simultaneous equation came from there, and some of our exponential equations came from there. I just want to show you in the last few minutes that we've got our question 1 and question 2. You're going to get questions like this. And if you know your equations and inequalities, it's a great place to start scoring your marks. We see 29 marks here from question 1, and 1.1.1, that is a basic factorized question. You can solve it in 2 seconds. Here, corrected 2 decimal places, you're using your quadratic formula. 113, you've got your quadratic inequality. 114 is a surd equation. It's a bit more complicated, but the idea is the same. Simultaneous equation, and then you've got some nature of roots. So those 29 marks should be fairly easy to really do well in. Question 2, we've got some exponents, which we didn't go over, but the rules of exponents are the same. Exponential equations, this is a rational exponential equation. Here is a basic one, here's another surd equation, and here question 2 gives you a total of 17 marks. So you really can do well in these sections if you make sure you know your algebra and your equations. All right, that's it for today. Next week we'll be looking at trig equations, so you can tune in next Saturday. Thank you everyone for being here. I hope it helped you with your section 1 in your paper 1 exam.